Hello, everyone. My name is CCP Amino. I'm a lead tools developer at CCP, and I work as part of the platform department. So we're the department that look after the Carbon engine, so the core components to power EVE Online and EVE Frontier. More specifically, I'm part of the tools team within that department, known as Team Gadget, and today I'm going to be joined by a couple of my colleagues, CCP Darwin and CCP Self, and we're going to give you a little behind-the-scenes look at at least one of the tools that we work on most of our time. One of the main developer tools that we provide to our artists and designers and gameplay programmers. We don't tend to get so in-depth with these tools usually, but with all the talk of going open source and open sourcing many of the components of our engine, we thought it would be nice if when we do all of that, once we've got all the graphic components and the audio and stuff all open source and ready for you to use, it'd be nice to give you at least one program that will show how those components can be used, how they can be put together, as well as give you access to some of those tools. So while you're working with the engine, you'll be able to leverage the power of that engine with the tools that we can provide. And so I want to introduce you to the Carbon editor known as Graphite. So Graphite is quite often thought of as being a big collection of various tools for various purposes, from specific editors for achieving certain artistic goals or design goals. But fundamentally, it's a little bit different from that. It's a sort of more of a framework in which we build tools specifically for artist and design pipelines. But at its core, what it is it's a little UI framework. We're using Qt as our basis. And it's a small little framework of utilities that we've put together that we attach to the engine while it's running. And then we can use that to do all kinds of things. We can use it as a basis for really complex tools, but fundamentally what it is a runtime we can use to inspect and debug live carbon-based applications. And so it's got three main components, and this is the first one. It's a tree view. It's a pretty simple idea. But one of the complicated things about having something like this is we have no idea what code someone is going to write for what object they're going to make, and they still want to have a UI so that they can explore everything they've made. And so the tree view has the main job of taking any arbitrary object a programmer has come up with or a designer has made and render it some way as a tree so it can be inspected and explored. We also have an attributes panel. We've got a couple of examples here. This is a very auto-magical UI. You make any object and put it in that tree, and when you click on things in that tree, we'll throw up an attributes panel. So there's an example of a simple one on the left and a more complex one in the center. And this provides all kinds of editor utilities shown on the right for doing sort of complex editing of values. But its fundamental job is to take any object at all and let you see all of the data about that object and edit anything it can provide controls to edit. And it does all of this automatically. It's not something that we pre-write for every game class that a programmer might make. They can do anything. They throw it at this. It gives you some kind of basic interface to edit it. And finally, obviously, Carbon, it's a Python-based application. If you are making a game in this, one of the things that's really useful is a live Python console. So you want to execute some arbitrary code, you have a console there. You want to inspect something or debug something, you have live access to the Python runtime environment in whatever you're doing. If you were to take a bunch of those open source Carbon components, put them together to make your own little Carbon-based application, a little Carbon-based game, you'd probably end up at a point where you have basically a blue screen. So nothing particularly interesting, but you put all this work in, you want to be able to see what's all of the data behind the scenes, what's actually going on to get to the point you can at least have a blue screen. And Graphite is, with a couple of lines of code, something you can attach to that process so you have full access to debug the innards of the application that you're making during runtime. When it gets a bit more complicated, when you've got something like the EVE client, Graphite's designed to scale with that kind of complexity. And it gives you this kind of out-of-the-box experience. So here, even with just the tree view, the attributes panel, and our console, this is me running with in a hangar. I can use this to explore the complexity of that scene, see all of the data artists have authored, go through it, live edit it. Maybe I'm just seeing how things work so I can build something similar myself, or you can use it to try out new ideas or experiment with things on the fly, see how things look, how they feel. But it's also a very important part of our art development process because it means that they can go in and see all of the art pieces that they've made running during the game so they can tweak the little intricate bits of timing, get things just right before they release them to you. But we also have Graphite in what we call standalone mode. So rather than just running attached to a Carbon process, you can actually run it in its own little editor mode. This is the mode that people use for all kinds of things, from making new art assets or building scenes for a trailer to authoring gameplay code and authoring game data. And it's in this mode that we build a whole bunch of tools. And here is the example of just a collision editor. Obviously, the collisions are very in-game, very game-specific things. So we need some kind of in-engine editor to be able to author that data so that we can get it right. We need something that's a bit artist-friendly, something that they can use for the new things that they're making. But beyond that, we also have things like the what we call the dungeon editor. This is the editor for in-game sites. We just call them dungeons for silly historical reasons. But the philosophy of Graphite is we tend not to build giant tools that do an entire job themselves. We have those basic tools like the tree and the attributes panel, and what we do is we build small tools that artists and designers will couple together on their own to build out workflows so they can achieve whatever it is they want to do. Because we can't often predict what people are going to want to use these for, so we have to have a philosophy of building things in a much more flexible way so people have room to experiment with what we provide. And you can use, this. Here we have a dungeon editor, so we can build out a cool-looking site, and our type browser, so you can go through every object that anyone has ever made for EVE Online for any reason at all. They're all here. You can explore them all in great detail, and you can use this for all kinds of things to see what has been used before, what people have already made, or just find a ship you really like. So that you can inspect it, take a look at it. How was it built? What's in there? How does it work? And we have also access to what we call the Space Object Factory. This is the way that we create space objects that we display in the game. It's powers our whole skinning system. So we have utilities in there to just go in, take a look, experiment, play around, skin things quickly. But we also have even lower level tools so that you can handcraft animations that you want to attach to an object or build out whole VFX or artistic pieces. And we can even have some sort of like basic replication of things that are in the game. So fitting turrets is a very EVE Online specific thing. So we have a turret fitter. So we have something basic for artists and designers to experiment with, see how things look and how they feel. Give them some way of demoing them away from EVE Online itself, and that way they can be free to experiment and play around without having to actually affect the game itself. So they've got a playground in which to try new ideas out and build new things. And sometimes you can use this entire thing to inspect all of the weird and wonderful VFX systems that have been built into EVE Online. You can get really down into the details, see how all of them work, how they're built, how they function. Or in this case, just play around with all of the state machines and see what things look like when they melt away for a bit of fun. And of course, if you take all of those components and write a bunch of arbitrary code yourself, because you're bored one Saturday night and you're a tools programmer with nothing better to do with his time, you can take all of the stuff and build a really bad version of Asteroids. It's good fun. But Graphite, no matter what you do, is there to provide you with the tools so that you can inspect even this random little toy that you've made for a bit of fun. You can still go through and inspect everything you've did, the ship classes you made, the asteroid class you built, so you can track their health and decide when they get damaged and how the thing should shoot. You can tweak all those numbers live and use this to debug things or just to tweak the feel of whatever little thing you're working on. And so what we want to do is, and we don't have a good timeline we can promise on this, our team's focus is, now as it always is, to provide more tools to artists and designers so they can build cool stuff for the games they make. That's always going to be our goal. But with all of the efforts to open source things, we are working on trying to get this to a point where we can make it work for you as well. We have no idea what you'll do with it, but to be honest, that's half the fun. We want to find out, see what people, weird and wonderful things people can do if we put this in their hands. And there's a long road to getting that working. I mean, for one thing, it's an internal developer tool. We know it works on our internal machines. That doesn't mean it'll work on yours. We have to go and do all that work to find out. And as part of that process, we've, over the last year, had to do a lot of work with porting to Python 3. That's one of the big milestones. So to give you a kind of idea of the work that's ahead of our team in order to get this to you, I'm going to hand it over to CCP Darwin, who's going to go into a bit more detail.
All right. Hi, I'm CCP Darwin, and I'm here to talk about how we've been porting Graphite to run on Python 3. If you've been attending any of the other sessions about our technical foundations this weekend, they've been talking about Python 3 quite a bit. The game projects are all moving toward using Python 3 as a foundation for everything they're doing. It's been one of the largest infrastructure projects that we've undertaken in many years, and it's taken about 2 years to complete overall. About 1 year of that has been working on updating Graphite in particular, and it's a great example of what we're doing as a company to try to improve our foundation for the future and make the games continue to be vital from a technical standpoint. So how do we use Python? Python is used with our Carbon engine. C++ is what we use for performance. So if we're doing really high intensity graphics work, that will be in C++. Python sits on top of it and is used to script things, is used to make all the gameplay logic. Python is for ease of development. Graphite isn't just for graphics, but it also provides an interactive Python shell, which I think you saw in CCP Amino's talk. The big reason we use Python is because it helps software developers move quickly, and they can build things fast without having to rebuild all the time. They can try something out and get it up and running in minutes. It also makes it easier for other developers who are not software developers, so for example, the game designers on the team, to read and understand the code that's been written to make the game run. Now, why do we want to move to Python 3? Well, Python 3 is the modern version of the language, and it's funny to say that because Python 3 has been around for about 17 years. We've been using Python 2 for 25 years. Python 2 was deprecated in 2020, so it's been 5 years during which Python 2 is not even supported anymore. But because we have so many millions of lines of Python code, it's very difficult to move off of it. So it's taken a very focused, invested effort to do that. Python 3 offers the promise of true multiprocessing, and we are not reaching for that right now. But the version of Python that we'll be moving to in the near future does allow experimenting with that. What we hope is that in the eventual future, this will make particularly our server code much faster, which will enable many more ships on grid. It'll allow you to do much more exciting things in the game and have a much more responsive experience. Our open source release is going to be in Python 3. It doesn't make a whole lot of sense for us to release open source in a version that nobody's used for 5 years and that is, was old 17 years ago. Now, what does Python 3 mean to the players? Well, today it looks and feels the same. When we move to Python 3, you should not experience any changes. It is a measure of our commitment to modernizing Eve. We are making our best effort to keep Eve modern, and this move to Python 3 is going to be a key part of that. And our open source release is going to be a lot more familiar to people who are experienced Python programmers, because almost nobody out there is using Python 2 anymore, and we want to present the same experience that you would have working on any other Python project. Now, Python 3 was a difficult project in a number of reasons. Python third-party libraries, which we rely heavily on, can behave very differently between Python 2 and Python 3. Some third-party libraries for Python 2 don't exist in Python 3. We also had the extra complexity that we were using a version of Python 2 called stackless, which was a fork of Python that had some special features in it. And we are we had to re-implement those features for Python 3 because there's not a version of Python 3 stackless that is modern enough for what we were trying to do. Eve and Eve Frontier both wanted to have different migration timelines, and the reason for this was appetite for risk. Eve Frontier is trying something entirely new, and they can blaze ahead and use new technology and push really hard on the cutting edge. Eve, on the other hand, has to continue to offer you a good gameplay experience, and so wants to wait to make sure that these changes are well tested and vetted and established as stable before moving on to Python 3. So for the time being, Eve Frontier is on Python 3 and Eve is on Python 2. And we have to support all of that in making Graphite. And we have, as you saw in the demo, we have many workflows, many features, many places for defects to lurk, and many possible edge cases where somebody may try something that nobody's done in a year or more, and it doesn't work. And so because of that, we had to find ways to implement Python 3 so that we could test and evaluate all of that and make sure that everything was in good shape. So our solution for this was to make a hybrid version of, Graphite. And the hybrid version runs on Python 2 and Python 3. It's the same basic code base. It solves the problem of multiple projects that want to migrate at different times. It supports both Python 2 and Python 3 with one version of Graphite, so we only deliver one thing and it works either place. And we do this with a compatibility module that we've made. The compatibility module knows all about the differences between Python 2 and Python 3. And then when we finally are ready to leave Python 2 behind, because Eve has moved on to Python 3, we can start with that compatibility module and have all of our differences in one place. Then there are binary dependencies. And binary dependencies are all the libraries that Graphite sits on top of. We use a number of third-party libraries, including the Qt graphics library for UI, Perforce for handling file management and file versioning. We have our own custom C++ library that handles some windowing stuff that we are doing in Graphite. And all of these things have to be different between Python 2 and Python 3 in order to work. So the way that we have solved that problem is we have two versions of all of those. And when you launch Graphite, it fires off a thing called update binaries, which copies the right version into the right place. So at the time we're launching Graphite, we have versions of all those libraries that present a consistent interface to Graphite, and they're appropriate versions for Python 2 and Python 3. Another way that we approach the question of getting working for both Python 2 and Python 3 is using a module that is publicly available. It's open source. It's called Six. And yes, the name is actually the word SIX, Six. It's a module that helps you build Python 2 and Python 3 hybrid code. It tells our code what version we're running. It provides common interfaces to modules that we that have moved or have changed their interfaces between Python 2 and Python 3. So to some extent, we can hide the differences in there and not have to put it into our compatibility module. And it's open source and freely available, so if you were working on your own Python 2 to Python 3 migration, I would say this would be a great place to start. If you're a programmer, some of this may mean something to you. Many of you, I'm sure, are not, but here are some of the differences that we had to deal with between Python 2 and Python 3. One of the things to keep in mind about this is that each one of these things taken individually is a pretty small thing. And if you had one line of code in front of you and you had to change it to fix it, it would be fairly easy to do. The problem, on the other hand, is that we had 250,000 lines of Graphite code, millions of lines of EVE Online code, and all of it had to be gone over to make these changes. So it's a question of volume rather than a question of technical difficulty. Now, how big was the Python 3 project? So in January, we merged our test hybrid version of Graphite into our release. So we released our hybrid version of graphite. In that release, 250,000 lines of code roughly changed, 1,713 files. Most of those 250,000 actually were new code that were added, so a lot of that was not stuff that we had to touch by hand. The other number, however, the 12,626, those were the number of existing lines that had to be modified in order to make Python, in order to make Graphite Python 3 and Python 2 compatible. So a human being was touching all of those 12,626 lines, and that is a lot of work. It took about a year. So development began in January of 2024. This is for Graphite only. The work for Python 3 for Eve was going on before that. We first launched Python 3 Graphite in February of 2024. We rolled out Python 3 in a Python 3 only version to Eve Frontier in September of 2024. And January of this year, we rolled out the hybrid Python 2 and 3 Graphite to both Eve and Frontier, so Eve's artists are using it today. And we're going to continue to iterate and improve on this into the future, and we're hoping that it will provide a great experience for those who adopt open source for this. To get back to a little more graphic excitement, I'm going to pass it on to CCP Self, who is right here.
Hey everyone, welcome. Glad to see you all here. It's a surprising amount of people. This makes me glad. I'm CCP Self, an associate tools programmer with the Graphite team. For the past 2 years, I've had the distinct honor of working closely with extraordinary artists. These are the visionaries who literally manifest space, technology, and raw destruction in Graphite Editor. Creations you then experience in New Eden. Now, in Graphite, the old rules don't apply. Forget the sky. The only limit is basically your graphics card. So, have you ever wondered what it truly looks like behind the curtain? What does wielding graphite actually entail? Let's take a look. What you witnessed, that maelstrom of fire and steel and bright explosions, that was brought to life entirely within Graphite. And it demonstrates the power that the artists wield. Graphite provides the canvas and the technical tools like the cameras and the recording suite, allowing even those with more on the technical side, like myself, to assemble visually stunning sequences by leveraging the assets and effects that our artists create. Now, to truly grasp Graphite's impact, not Genshin impact, that's something completely different. Nobody? Good. Okay. To truly grasp Graphite's impact, we must peel back the layers on how assets exist in Eve. Imagine assembling a behemoth like this ship. Its components, resources, models, etc., they aren't neatly packaged. They're scattered fragments across our vast digital universe, residing here and there in our file system. And I'm using ships as an example, but the same intricate web applies for stations and cosmic phenomena, in fact, all complex entities in space. And for every piece of the puzzle, be it a red file, a resource, or a database entry, they all must exist, connect, and harmonize. The critical point, every digital thread must be perfectly woven into the final creation, ship, hangar, station, to emerge into a functional reality. Now, forging a cataclysmic fury, an explosion, it demands more than just fiery assets. It requires It requires weaving them into the universe's fabric, translating complex code into a visual medium. It provides, and this is where graphite becomes the artist's essential partner. Wait, the video is broken, I guess. All right, well, that happened. Okay, I'll just go without the video. It shows just how artist authors an explosion. So, graphite it doesn't just read scattered data. It channels the fundamental rules of carbon, linking raw power to structured data. It provides sophisticated tools designed to unleash the artist's vision, empowering them to sculpt creation and destruction with nuanced control. Let's take a look at the environment where this mastery unfolds. On the left, we have the tree view. This is the strategic map of this cosmos, revealing the intricate hierarchy. Artists navigate this structure from minor components to vast installations. They select not only objects, but also core systems, like the rendering engine, the fundamental gears of this reality. Select anything, ship, station, hangar, the engine, and its core DNA will immediately be revealed in the attribute panel on the right. This is the inspection bay. It reveals all of the defining traits, all the tunable parameters for the artist to command. This is an incredibly versatile tool, from precise numerical inputs and text fields to rich color palettes and vector data. It even extends to sophisticated custom interfaces designed to unleash the artist's vision. The custom interfaces that are specifically designed to harness unique Eve mechanics. When artists require deeper finesse, like with intricate physics or evolving behaviors, the graphite provides dedicated windows, specialized environments for that crucial refinement. And for exploring an explosion, we have the curve editor. Now, this isn't just data. This is the timeline of destruction. Here they become the maestro, conducting the explosive crescendo. Oh, there we go. Freezing an explosion mid-blast, sculpting timing, refining every microsecond. This potent tool empowers the creation of not only effects, but the fluid animations and the sweeping cinematics that define Eve. So, what happens when you provide the artist with an incredibly deep customization and an intuitive interface? A small cake, no. You enable them to achieve spectacular results. And in some cases, you even get some truly memorable descriptions of these experiences. When we asked CGP Myrkur, what's it like to create explosions? He gave us this fantastic analogy. It's like milking a cow, but the cow's on fire, the milk is pure energy, and the farmer's crying. We take that as a great compliment. Meet our ship, Bob, the Planet Destroyer. A truly magnificent vessel, wouldn't you agree? Now, such magnificence demands an equally striking appearance. So let's name Bob, and let's bestow upon it colors befitting its purpose. This is the cosmetics browser. Here, the artists conjure and publish colors and patterns, which the game designers then weave into the game's data tapestry, making them available finally in the Skinner tool in the marketplace. Here, we're going to create a color of planetary destruction. And the canvas on the top right, you might remember the concept from 3D graphics. This is Carbon's equivalent of a Utah teapot or a standard reference test model. Artists rely on this tool extensively to rigorously test hues and glow intensities against various angles and all conceivable curves to make sure that colors behave perfectly on a vast sea of hulls. So, with our color crafted, let's then apply it to Bob. And we're going to do this using our custom Skinner widget. It's one of the Eve specific widget that we have. And let's put some more fearsome colors. We're going to destroy a planet after all. We can even sort by color. We can search colors by color by calculating the Euclidean distance between the 4 color vectors of the color. I just wanted to say that for no particular reason. And yeah, we have some striking colors. I believe Bob is, well, what do you think? It's looking pretty cool, right? Let's put also a pattern fitting its incoming annihilation. All right, our fledgling is just about ready. Now, planetary destruction. Such artistry often precedes kinetic application. For the kind of cosmic storm we intend to unleash, a catalyst is required. I mean, sure, when thinking about large-scale destruction, we can just press the bomb button. But true, methodical planetary unmaking, it demands more than just flipping a switch. Every proper celestial detonation requires something incendiary. It requires hardware capable of the task. So let's arm Bob appropriately. We shall outfit our planet destroyer with turrets capable of leveling a planet. And for that, we have the turret fitter, where we can search turrets by group, family, or size. We're going to need something big for Bob. So let's put on some big turrets. That's looking pretty nasty, but I mean, it still lacks a certain weight. I mean, we have to destroy a planet after all. So let's go even bigger. Yeah, there we go. I like that. I can practically hear the hum of planetary demise. Let's put 5 of those beauties. Fits perfectly. I believe Bob is just about ready, our fledgling, growing up to destroy a planet. Now, with our ordnance secured, it's time to select our planetary victim. Behold, the planet spawner. This isn't just about crafting celestial bodies. It's about curating worlds from established archetypes. We can configure their fundamental nature using templates, sculpt their surfaces with diverse height maps, and even introduce randomness with random seeds. For today's demonstration of graphite's power, let us conjure forth a stark, barren world and place it onto our celestial canvas. Yeah, it's just begging to be destroyed. Now, before we end, I'd just like to say one thing. Our vision extends beyond today. Our team is charting a course to open sourcing graphite, ultimately aiming to empower you, the community, to get a closer look and potentially build upon these foundations. Now, without further ado, by the power of graphite, fueled by carbon, go forth, oh Bob, you little rascal. I'd like to welcome CCP Amino and CCP Darwin back to the stage. That concludes our deep dive into graphite. On behalf of platform, and Team Gadget. Thank you all profoundly for joining us today.
I believe we're opening it up to Q&A.
Sorry.
Q&A, we're going to open it up for people to ask
Oh,
questions.
yeah, that's why I'm at the back. We were going to open for Q&A.
Yeah.
Yeah, go ahead. All right, do you want to grab a mic?
Thank you.
Simple question. You want to open source this. Is that going to include the actual Eve assets? Are we going to be able to make our own introduction videos for our corps, for our fleets, using the Eve assets?
So that hasn't been decided yet. We're hoping that we can basically let you do anything that you could, any of the assets that are in the game. But that's what we would like, and the decision lies with the art team of both projects rather than us. But maybe.
We would love to.
Yeah, there will almost certainly be some kind of assets packaged up, but whether it's a very small set, whether it's a lot, what it is, it hasn't been decided yet.
Yeah, bottom row.
Just a quick question for the migration process from Python 2 to 3. Was it purely human labor, or did you use any of the latest and greatest in the AI code generation for just upgrading codes or just quality assurance? Just see where you are. I mean, it was probably a bit early at that time, so I don't know if you use any of the AI in terms of migration from Python 2 to Python 3.
Sorry, you're mentioning the migration in regards to AI.
Yeah, when you went from Python 2 to Python 3, did you use any of the AI tool, or was it just pure human labor, just line by line, everybody was coding?
It was mostly human labor. There were some automations, but it wasn't like we needed some grand AI to do it. A lot of the modifications are things you can describe. So we had some, there are some suites that help out, that help do some of the basic conversions. And then we had some utilities that we made ourselves. And then beyond that, because most of the work was try something, watch it break, and then do the very obvious fix. And so most of it was manual.
Yeah, one of the issues with moving from Python 2 to Python 3 is that in many cases there's a little bit of a conceptual shift between how the two versions of Python handle certain things. A big example of that is string processing, where everything has moved from being a byte-type representation of ASCII strings to Unicode. And in that transition, it often required taking a step back and rethinking how we were doing fundamental things in terms of that work. And string processing is a surprising amount of what Graphite has to do, considering that we have a lot of string-type data in our assets. So.
In regards to model importation into Graphite, what kind of file types do you support? I know a lot of the Eve stuff is packaged in GR2s and FBXs. What kind of models can you bring into Graphite?
So right now, it's limited to the proprietary GR2 format. We're hoping to change that. It's one of the things that we want to do before we open source this. It's one of the things we have to fundamentally change is, if we're going to give this to you, you have to be able to use the things. So we were looking, I think, mostly at FBX. We also have a thing I showed at last Fanfest that we call the Carbon Conduit. I didn't have a chance to create a video of it here, but we have a set of Blender tools. So we're trying to build out a pipeline so that when you author things in Blender, there's a pretty automatic process from Blender that will do all of the work of massaging all the files and put them into something you can use directly in Engine. Preferably, well, not in real time. We're hoping to get this down to, a second or so for the update process. So far, it's reasonably successful, but porting meshes is the next step. So we might not in the end have FBX or USD file support, but we'll have some way of going from something you can do in Blender straight into the engine.
Okay, thank you.
And of course, one of the reasons that we use Granny for everything we do is because it's highly optimized for use in an engine. So whatever format replaces it or is added to it is going to end up being something which also has that property. So coming directly from, say, an FBX file might be less likely than having some type of conversion tool.
and thank you for your presentation. Could you tell us a short story of the best thing that went wrong?
It's an excellent question.
No. I'm just kidding.
I think the main things that have always gone wrong is because I've worked on these tools for a very long time. Most of the worst things that have happened is I did something that was dumb and bad and wrong, but it solved a problem for an artist that day immediately, and now I can never delete that, and I constantly have to work around it. So this is just the constant problem of, this will fix this, we've got a release going, let's make it work, and then I'm still dealing with the problem I created that day a decade later.
Yeah, unfortunately, I wish I could tell better stories than I can remember off the top of my head, but I've put a lot of this out of my mind in retrospect, now that we have it all working. Let's see.
Any other questions? Oh, got a couple.
Sure. Oh, sorry. He's heading up there with
Hey guys, thank you for the presentation. It's a very strange question, but as tools programmers, do you have a favorite asset, each one of you?
Favorite asset?
Oh, I mean, mine's the prophecy that I used for the little game.
I kind
Because
of
it used to be the default one that popped up every day, so it was the one I saw every single day when I was solving any problem.
I don't know if you guys are familiar with the Apocalypse ship. That's the one I use the most because it's the first one in the alphabet in the builder. So what I primarily use to my
I
work.
kind of love the Macarial, actually. That's my.
I did
my favorite.
at one point get really upset because someone renamed an asset, so it started with a number and it became the first thing in the alphabet. So for a while we just had a boring blob
As like the default.
as the default. We had a question down here?
What was your favorite tool to build?
Oh, sorry?
What was your favorite tool to build?
Favorite one? That's a toughie. There's been a bunch. I'd say the one that I had probably the most fun making was the site editor. And the reason for this, we built that before Abyssal Dead Space. And the big reason that we did it was so that we could finally have artists like involved in actually laying them out. We had a problem before where artists would design beautiful scenes and then a poor designer would have to sit there and try and recreate it. So making something we could give to an artist, but like, you can just do this and it'll work, was very satisfying. But the other one that I enjoy was just a very simple tool that just gives our VFX artist a list of things they've made. It's like one of those ideas you have in 5 minutes and then suddenly you realize it fixed a whole bunch of problems. So a tiny little idea that has all of this wonderful benefit, that was incredibly satisfying. That's the FX helper menu.
Okay. I think the thing that I liked the most was Arne and I worked, I'm sorry, CCP Self, and I, who? Worked on a character editor, which gives you access to all of the Eve character building tools for 3D characters. And that was complex and fun and had a lot of moving parts, and when it all worked, it was really super fun.
Yeah, I guess favorite tools I make is the one that makes the workflow a lot faster and allows the artist to do things in a much faster way than it did before. Like the example of this is, for example, the type browser and the cosmetics browser, where you can just you don't have to go through lists anymore. You can just see it and you can search for it in a search engine, and that's very satisfying for me to do that.
Yeah, oftentimes it just comes down to seeing what people did with it after you were done is what makes it satisfying.
All right, I think we're out of time. Thank you so much. If you have any other questions, please feel free to contact us afterwards, and we're happy to chat.